448, find all numbers disappeared from an array. So given an array where the numbers are supposed to represent 1 through n, return an array of all integers in the range 1 through n that do not appear in nums. Okay, so here's the input. We have all these numbers. Visually we can see that 5 and 6 do not appear in 1 through 8, and 3 appears twice, but that's not relevant to the problem, and 2 appears twice, that's not relevant to the problem. 5 and 6 are missing from this array. Okay, so basically I'm going to use a strategy of marking the numbers in this array, and we're going to mark them with -1 if we've already been to them. And in the end, we're just going to find all the numbers that don't appear in the array, that haven't been marked. Clarification, not the numbers themselves, but the index of those numbers. So what's our marking strategy? Our marking strategy can't just be to linearly scan C. So 4, have I seen that before? 3, have I seen that before? I can't really ask the question, have I seen that before? Because in order to do that, I would have to compare it with something such as a set, and that would take up extra space. So what's a way of asking the question of have I seen this? Have I seen this before without having a set? So we want to use the teleportation traversal. Array teleportation traversal. So here's what I mean by that. So at index I is equal to 0, we're going to have number 4 right here, but we're going to do nums minus 1. So first, let's ignore this nums minus 1 to see why we need it, okay? So our first number is 4, okay? If I go to index 4, that gives that gives me 8. If I go to index 4, that gives me the number 8. I want to mark the number index 8 as visited, but there is no index 8. So therefore it's going to be nums minus 1. So I mark the value at number 3 as visited. Put a -1 right here. So that's 7. Next, go to index 1. Index 1 is 3. 3 minus 1 is 2. I go to this index and I say I've visited. Next, I go to index 2. 2 is number 2 is 2. Minus 1 is 1, and I say I've visited. Next, go to index 3, which is 7. 7 minus 1 is 6. Number at 6, say I've visited. Next number is index number 4. That's 8. 8 minus 1 is 7. And I say I've visited. Next is number 5. Index 5 is 2. 2 minus 1 is 1. Index 1 I've already visited. Do nothing. Index 6 is 3. 3 minus 1 is 2. And I've already visited. And then number 7 is 1. And that gives me, and 1 minus 1 is 0. And I say I've visited. So if I change this to 1 through n, just add everything plus 1. You'll see that I haven't visited number 5 and number 6. not index 5, index 6, but number 5 and number 6. So basically you just do another linear scan and you see which ones are positive, and then you find the index and then just index plus 1. And that's pretty much how you do this problem. Let's do the code now. So first step, mark visited, use teleport scan, use array teleport scan to mark the visited and add to the list. Okay, so first we're going to do a simple for loop. Simple for loop, and we have I, and then we have our num, and that's going to be nums I minus 1, but when we do nums y, we want to be this do math.absolute, and that's the index where we go to. So I guess we'll call this new index. So I multiply it by negative. First we check, I guess, see if we visited before. So if it's greater than 0, we haven't visited before, and let's mark it. If we haven't visited before, then we mark it. If we've been to it, just ignore it. So this will do the whole marking process. After we do the marking process, for loop. This should be it. Boom, great job. Space complexity, I think they said we don't count this list. You may assume this does not count. So this doesn't count as space, so it's O of 1 constant, and we're doing it in constant time.